Hello students. So ಇವತ್ತಿನ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ನಾ ಏನ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂತಂದ್ರೆ ಪ್ರೀವಿಯಸ್ ಇಯರ್ ಅಂದ್ರೆ KCET 2020 ಎಕ್ಸಾಮ್ ನಲ್ಲಿ ಬಂದಿರುವಂತ ಕೆಮಿಸ್ಟ್ರಿ ಕ್ವಶನ್ಸ್ ಅನ್ನ ನಾ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಹೋಗ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಲೆಟ್ ವಿ ಗೋ ಫಾರ್ ಸಾಲ್ವಿಂಗ್ ದೋಸ್ ಕ್ವಶನ್ಸ್. ಬಿಫೋರ್ ಸ್ಟಾರ್ಟಿಂಗ್ ಯಾರೆಲ್ಲ ಇನ್ನ ನನ್ನ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿಲ್ಲ ಪ್ಲೀಸ್ ಎಲ್ಲರೂ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ಜೊತೆಗೆ ಅಲ್ಲೊಂದು ಬೆಲ್ ಐಕಾನ್ ಇರುತ್ತೆ. So please press the bell icon for future in videos. First question. Copper is extracted from copper pyrites by. Okay, here this question is arrived from the chapter metallurgy. And what is the composition of copper pyrite? It's CuFeS2, which is nothing but copper pyrite. So what is the reaction that takes place during the extraction of copper? So I have to write the net cell reaction like copper oxide, which is known as cuprous oxide. Cuprous oxide on treating with Cu2S, that is copper sulfite. Copper sulfite. So which gives a 6 atoms of copper with the liberation of sulfur dioxide. And this reaction is known as auto reduction reaction. So for question number 1, it's option D, auto reduction. Then question number 2, functions of potassium ethyl xanthate in froth flotation process is to make the ore. We know that. So here potassium ethyl xanthate that acts as hydrophobic. What is meant by hydrophobic? So ಎರಡು different terms ಬರುತ್ತೆ. One is philic, another one is phobic. So philic means which has some affinity, and phobic means no affinity. So the terms are hydrophilic and hydrophobic. Now you can get the term hydrophilic andre the substance which has the affinity towards water, and hydrophobic andre there is no affinity towards water anta. So in this process potassium ethyl xanthate that acts as hydrophobic substance, and which is to make the ore water repellent. To make the ore water repellent. And here the metallic ore particles are preferentially wetted by the oil and rise to the surface with the froth. So other oils used in this process are pine oil, then eucalyptus oil, and fatty acids. So ಬೇರೆ ಕ್ವಶನ್ಸ್ ಅಲ್ಲಿ ಈ ಆಪ್ಷನ್ಸ್ ಕೂಡ ಇರಬಹುದು. So that other oils used in this process, that is froth flotation process, are pine oil, eucalyptus oil, as well as fatty acids. So in the question number 2, it's option B, which acts as hydrophobic substance, water repellent. Then question number 3, sulfide ore on roasting gives a gas X. X reacts with the chlorine in the presence of activated charcoal, gives Y. Then in the reaction Y is, okay, for this we have to write the reactions. ನೋಡೋಣ ಯಾವ್ದೆಲ್ಲ reactions ಬರುತ್ತೆ ಅಂತ. So sulfide ore means Cu2S, which on roasting ಅಂತಂದ್ರೆ heating the substance in presence of oxygen. So 2Cu2S on heating in presence of oxygen gives 2Cu2O with the liberation of 2 molecules of SO2. So this is the reactions involved in roasting. Okay, here the first sentence like sulfide ore on roasting gives a gas X. So here the gas X, which is nothing but sulfur dioxide. Then what is the second step? Here they have given X reacts with chlorine in presence of activated charcoal gives Y. So just now we have found out what is X, that is SO2. Again, SO2 on treating with chlorine molecule in presence of activated charcoal. In presence of activated charcoal, which gives the compound SO2Cl2, which is Y in the given reaction. So, which is the correct option then? It's option A, SO2Cl2. Then, question number 4. Aqueous solution of salt A forms a dense white precipitate with the BaCl2 solution. The precipitate dissolves in dilute HCl to produce a gas B, which decolorizes acidified KMnO4 solution A and B respectively. Okay, so here also now number of steps of reactions anna baribekagutte. Aqueous solutions of salt A forms a dense white precipitate with BaCl2. We know that sodium sulfite Na2SO3 on treating with the BaCl2 gives a dense white precipitate. Dense white precipitate, which is nothing but barium sulfite. So ion exchange reaction takes place here. So just displacement reaction anta kuda helbodu, which is going to form a byproduct NaCl. So here barium sulfate gives a dense white dense white precipitate. So the second step is the barium sulfide formed BaSO3. Okay, here they have given the precipitate dissolves in dilute HCl. So that barium sulfide dissolves in dilute HCl, which gives barium chloride, then sulfur dioxide and water molecule. Among these products, sulfur dioxide, it acts as the gas B, which is gas B, because we know that sulfur dioxide decolorizes, which decolorizes acidified KMnO4, acidified KMnO4, because of its reducing nature, because of its reducing nature. Okay, what is the reaction that gives the information about sulfur dioxide decolorizes the acidified KMnO4? So here is the reaction when 2 molecules of KMnO4 are treating with 5 molecules of SO2 in presence of water, which gives K2SO4 with the liberation of manganese sulfate and sulfuric acid. So this reaction gives the information about sulfur dioxide that decolorizes acidified KMnO4 because of its reducing nature. So then, which is the correct option? It's barium sulfide, which is having dense white precipitate, and sulfur dioxide, which decolorizes acidified KMnO4 solution. So it's option A. Then question number 5. Bond angle in pH4 plus is more than that of pH3. This is because, okay, let me consider here. We know that if you consider pH3, which has lone pair on phosphorus, so here we can expect lone pair electrons on phosphorus, that is the central atom, but which is absent in that pH4 plus. So in pH4 plus molecule, it lacks the lone pair electrons on central atom, that is phosphorus. But if you consider pH3 molecule, the central atom phosphorus, that consists of lone pair electron. Hence, if you consider pH3, which is having bond pair, lone pair, repulsive interaction or repulsion. And if you consider pH4 plus, which is having bond pair, repulsive interaction. And we know that repulsive interaction follows the order lone pair, repulsive interaction is greater than lone pair, bond pair, which is greater than bond pair, interaction. So here we can clearly tell that bond angle in pH3, which is lesser than bond angle in pH4 plus. Because of bond pair, interaction, bond angle of pH4 plus is greater than pH3, which having bond pair, lone pair interaction. So that for question number 5, it's option A. In pH3, lone pair, bond pair, repulsive interaction is there. Then question number 6, incorrectly matched pair is. So they have given the options like XeO3 pyramidal shape, XeF4 tetrahedral shape, XeF6 distorted octahedral, XeO4 square pyramidal. Okay, so you can observe the diagram of these xenon compounds like XeO3. So if we consider XeO3 molecule, which is having pyramidal shape, pyramidal is also called as trigonal pyramidal geometry, and here xenon undergoes sp3 hybridization. So option A is correctly matched. Then option B, XeF4. So here we can observe the molecule XeF4, which consists of 4 bond pair and 2 lone pair students. So XeF4 molecule, which consists of central atom xenon, consists of 4 bond pair and 2 lone pair. And here xenon undergoes sp3d2 hybridization with the square planar geometry. Then XeF4, they have given tetrahedral. So which may be the correct option, that is incorrectly matched pair. Let me go for option C and D also. XeF6. So if you consider XeF6, which consists of 6 bond pair and 1 lone pair students. So here we can observe there are 6 bond pair, that is xenon, which is bonded to 6 fluorine atom, and there is a presence of 1 lone pair electrons here. And its geometry is distorted octahedral, So option C is also correctly matched. Then option D, XeOF4. So here we can observe XeOF4. So which is having a square pyramidal geometry. With sp3d hybridization. Here xenon undergoes sp3d hybridization. So for question number 6, it's option B. 7. Phosphorus pentachloride. So given options are on hydrolysis gives an oxoacid of phosphorus, which is tribasic. On hydrolysis gives an oxoacid of phosphorus, which is a good reducing agent, has all the 5 equivalent bonds, exists as an ionic solid in which cation has octahedral structure and anion has tetrahedral structure. Okay, let me consider, we have to write the reaction for this. Phosphorus pentachloride, PCl5, on hydrolysis. So on treating with 4 molecules of H2O, which is going to form a compound, that is H3PO4. Name of the compound is phosphoric acid, and with the liberation of 5 molecules of HCl. And here the product obtained is phosphoric acid, which is having the structure like P double bond O, then remaining 3 POH bonds. So here we can observe three hydrogen atoms, all those three hydrogen atoms are directly attached to oxygen. So that which is considered as tribasic acid, which consists of three replaceable hydrogen atom or H plus ion. So for question number 7, it's option A. Phosphorus pentachloride on hydrolysis gives an oxo acids of phosphorus, that is phosphoric acid, which is a tribasic in nature. Then question number 8. Identify the set of paramagnetic ions among the following. So what is meant by paramagnetic? If the substance that contains unpaired electron, then which exhibits paramagnetic nature. Okay, let me write the electronic configuration of given ions. So Ti3 plus, Cu2 plus, Mn3 plus. I will write the electronic configuration for these three ions first, then we'll go for the remaining ions. So if you consider Ti3 plus, titanium, which is having atomic number 22, but it's in 3 plus oxidation state. So which the electronic configuration is argon 3p5, argon 3p5. Let me write the complete electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p5, which consists of unpaired electron in p orbital. So argon 3p5. So which consists of, sorry, it's not argon 3p5, it's 1s2, 2s2, 2p6, 3s2, 3p5. If I write the complete electronic configuration, then it is argon 4s2, 3d2. So which consists of unpaired electron. Then if you consider Cu2 plus, so we know that copper is having the atomic number 29. And if I write the electronic configuration of copper in its 2 plus state, that is 1s2, 2s2, 2p6, 3s2, 3p6, up to this, which is argon, then 3d9. So which is also consists of unpaired electron in d orbital. Then manganese, which is having atomic number 25. And if I write the electronic configuration of manganese in its 3 plus oxidation state, it's 1s2, 2s2, 2p6, 3s2, 3p6, 3d4. So here, which is also consists of unpaired electron in d orbital. So these three sets of ions like Ti3 plus, Cu2 plus and Mn2 plus, they consist of unpaired electron. Hence, they are considered as paramagnetic ions. So if you consider option A, in that Ti4 plus, which do not consist of unpaired electron. If you consider option B, in that Zn2 plus, which do not consist of unpaired electron. And if you consider option D, V3 plus, which do not consist of unpaired electron. If you consider option C, all those set of ions are consists of unpaired electrons, hence they are said to be paramagnetic ions. Question number 9. How many moles of acidified K2Cr2O7 is required to liberate 6 moles of I2 from an aqueous solution of I minus? So let me consider the reaction first. K2Cr2O7 plus 6 Ki plus 7 molecules of H2SO4 gives rise to 4 K2SO4 plus 3 I2 plus Cr2SO4 thrice plus 7 molecules of water. So according to this above reaction, 3 moles of I2 requires 1 mole of K2Cr2O7. So 3 moles of iodine requires 1 mole of K2Cr2O7. But in the question, they have given 6 moles of I2. So here we can observe, in the question, they have given How many moles of acidified K2Cr2O7 is required to liberate 6 moles of I2? If for 3 moles it requires 1 mole of K2Cr2O7 means for 6 moles of I2 which requires cross multiplication 1 into 6 divided by 3 which gives 2 moles of K2Cr2O7, that is potassium dichromate. So the correct option is option A. And this question is nothing but the oxidizing property of potassium dichromate in acidic medium. Then question number 10. Cu2Cl2 and CuCl2 in aqueous medium. Let me consider these two compounds Cu2Cl2 and CuCl2. If you consider the size of Cu2 plus, which is smaller than size of Cu plus ion, as we know that if the charge on cation increases, its size decreases. Then the hydration enthalpy, which is also known as solvation enthalpy. The hydration or solvation enthalpy depends on the size of cation. And what is the relation between hydration enthalpy and size of cation? So I will write it here. Smaller the size of cation, greater is the hydration enthalpy, or larger is the hydration enthalpy. And hence, more will be the stability. So, which is the correct option then? It's option A. CuCl2 is more stable than Cu2Cl2 because of its smaller size of Cu2 plus ion. Then, question number 11. The coordination number of iron and cobalt in the complex ions FeC2O4 thrice to the power 3 minus and COSCN 4 times to the power 2 minus are respectively. So let me consider the complex first. FeC2O4 thrice to the power 3 minus. Here, if you consider the ligand present in this compound is C2O4 to the power 2 minus ion, which is nothing but oxalate ion. And we know that oxalate ion is bidentate ligand, which is a bidentate ligand, which means which can donate 2 pair of electrons towards the central metal atom. And here we have 3 oxalate ions. If one oxalate ion donates 2 pair of electron, 3 oxalate ion can donate 6 pair of electron towards the central metal atom. So that iron is having the coordination number 6. And if you consider the second complex like COSCN 4 times to the power 2 minus. And here the ligand present is SCN minus, that is thiocyanate ion. And we know that thiocyanate ion is a monodentate antandre, which can donate only 1 pair of electron towards the central metal atom. So how many thiocyanate ligands are attached to the central metal atom cobalt? It's 4. Then cobalt is having the coordination number 4. Then the correct option here in question number 11 is option D. Coordination number of iron and cobalt in these complex are 6 and 4 respectively. Then question number 12. Number of stereoisomers exhibited by COEN twice Cl2 to the power plus is. So for this, we can have these three isomers, that is stereoisomers. So among three stereoisomers, two of them are cis form and one form is trans form. So that for question number 12, it's option D, which consists of three stereoisomers. Question number 13. Give the IUPAC name of PTNH3 4 times PTCl4. Okay, here if we write the complex like PTNH3 4 times and PTCl4. Okay, first we have to write the cationic complex like tetramine. There are four ammonia groups are there, hence we have to write tetramine platinum. The metal present is platinum, and here in this coordination sphere platinum that consists of oxidation state 2, that we have to write it in the parenthesis. Then tetrachlorido, because we have 4 chlorine atoms or chloride ions that is attached to platinum. Tetrachlorido platinate, that in anionic complex the metal atom is ended with the term ATE, which is also having oxidation state 2. Hence, the IUPAC name of this complex is tetramine platinum 2 tetrachlorido platinate 2, which is option D. Then, question number 14. Prolonged exposure of chloroform in humans may cause damage to liver. It is due to the formation of the following compound. Okay, let me write the reaction for this question. Chloroform is nothing but CHCl3, trichloromethane. So, prolonged exposure of chloroform in humans may cause damage to liver because which is going to form a poisonous compound by the name phosgene. So, phosgene is nothing but cobalt chloride, which is highly poisonous. Hence, which causes damage to the liver. So, for question number 14, it's option B, COCl2, cobalt chloride. Then, question number 15. Which of the following halides shows highest reactivity towards a SN1 reaction? Okay, this is most interesting question because we know that rate of SN1 reaction is directly proportional to stability of carbocation. So I will write the carbocation as C plus because carbocation is nothing but if positive charge is present on carbon atom, which is known as carbocation. And here among the given options, C6H5CH2 plus, that is option A, C6H5CH2Cl on dissociation gives C6H5CH2 and positive charge on carbon atom. So, which is more stable and which is stabilized by the resonance, which is stabilized by the process called resonance. Hence, for question number 15, it's option A, C6H5CH2Cl. Then question number 16. In the reaction, so you can observe the reaction here. So let me consider the IUPAC name of this compound. If this is a functional group, then carbon numbering start from here. So 2-methyl 2-methyl propyl magnesium bromide or isobutyl magnesium bromide on treating with CH3NH2, that is primary amine, in presence of dry ether gives X. The number of possible isomers for the organic compound X is. Okay, for this, first we have to observe the reaction that takes place here. So the given reaction forms the compound isobutane, and which is having one more isomer, that is butane, normal butane and isobutane. These are the possible isomers for the organic compound X. So for question number 16, it's option D, which can form two possible isomers. One is butane, another one is isobutane. Then 17, which of the following on heating gives an ether as major product? Okay, here C6H5CH2Br plus CH3ONA, C6H5ONA plus CH3Br, CH3 thrice CCl, CH3ONA, C6H5CH double bond, CHCl plus CH3ONA. Okay, I think you are familiar with the reaction, named reaction, Williamson's ether synthesis. Williamson's ether synthesis. Okay, in this Williamson's ether synthesis, we know that primary alkyl halide and benzyl halides, primary alkyl halides and benzyl halides reacts with, okay, we'll write a plus here, reacts with alkoxide or phenoxide. So I consider both the cases, alkoxide or phenoxide, and the reaction takes place with respect to SN2 mechanism, and which gives ether. This is the Williamson's ether synthesis. Okay, here we can observe aryl halide, which is least reactive. If you consider aryl halide, I will write the general molecular formula, benzene ring with X. Aryl halide, which is least reactive. Why it is least reactive? That we know that the CX bond in aryl halide is considered as the character of partial double bond. So which consists of the characteristics of partial double bond. Hence, it does not cleave easily. So that S is not possible. And if you consider tertiary alkyl halide, which is also least reactive among the order of reactivity, so that R is also not applicable. Then remaining P and Q, these combination on heating gives an ether as major product. So for question number 17, it's option D. Then 18, the steps involved in the conversion of propane 2-ol to propane 1-ol are in the order. So here we can observe the reaction. Propane 2-ol on treating with or on heating with PCl5 molecule, then followed by heating with alcoholic potassium hydroxide. Then here we can observe this reagents, which is respective of hydroboration oxidation. So for question number 18, it's option C. Heating with PCl5, then heating with alcoholic FOH and hydroboration oxidation, we can convert propane 2-ol to propane 1-ol. Then question number 19, which of the following is the strongest base? So they have given acetate ion, chloride ion, then hydroxide ion and methoxide ion. So here, if you consider methoxide ion, So how we can obtain methoxide ion? So which is a conjugate base of methanol. Conjugate base of methanol, that is CH3OH. And we know that CH3OH, methanol, is a weak acid. Weak acid. Why it's weak? It is weak acid because of its Ka value, which is very small. Hence, it is considered as weak acid. So, its conjugate base, that is CH3O minus, which is very strong base. Very strong base. So, for question number 19, it's option D, CH3O minus. Question number 20. Benzaldehyde on treating with acetaldehyde in presence of dilute NaOH, which gives P. The product P in this reaction is, okay, if you observe those reactants as well as reagent in this reaction, so we can clearly predict that the reaction is Aldol condensation reaction. Aldol condensation reaction. So, because of the two different reactants, that is two different aldehydes present in this reaction, hence, which is considered as cross aldol or mixed aldol condensation. Okay, for this, I will write the mechanism. Just observe. First, I will write benzaldehyde here, C double bond OH. Then I will write acetaldehyde like this, CH3, C double bond OH. Okay. In this reactant like acetaldehyde and benzaldehyde, so this carbon atom present, that is attached to the functional group carbon atom. Let me consider this as alpha carbon atom. And this alpha carbon attacks to carbon that is having functional group, that is carbonyl carbon atom of benzaldehyde. Then to balance the valency of carbon, this double bond is shifted to oxygen, and here this hydrogen leaves as H plus ion. And in the next step, the product formed is, so here we can observe C single bond O minus, then hydrogen which is present as it is, then there is a single bond between these carbon of benzaldehyde and acetaldehyde. So CH2 group that is present as it is, then C double bond OH, and this hydrogen leaves its position as H plus, then it is attached to oxygen that is carrying O minus charge. So which is going to form alcoholic functional group. Then on heating the above byproduct, removal of water molecule takes place here. So removal of water molecule takes place to give a final product. So this water molecule removes, and the hydrogen leaves as H plus by donating the electron towards carbon atom, so that the product obtained is benzene ring with CH double bond CH single bond C double bond OH, which is the product obtained here, that is alpha, in alpha position, alpha beta unsaturated aldehyde. Alpha beta unsaturated aldehyde is the general product obtained in this aldol condensation. So the correct option for question number 20 is option D. Sorry, it's not option D, it's option C. C6H5 CH double bond CH CHO. So students, I will stop it here, and the remaining questions we will discuss in the next video. So ಯಾರೆಲ್ಲ ಇನ್ನು ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿಲ್ಲ, ಪ್ಲೀಸ್ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ ಅಂಡ್ share it with your friends. Thank you.